In this video, I'll be showing you the derivation of the simple torsion formula for a cylinder. In this sketch, this is the cross-sectional area of this part of the cylinder, and it's important to realize that this arc length is the same as this arc length. So we know that these two are equal, therefore by the arc length formula, S equals R alpha and S equals lambda L, and lambda is the shear strain. We can equate these two formulas by saying R alpha equals L lambda, and this results in this formula. This is because the shear modulus G is equals to tau over lambda, the shear stress over the shear strain. I've named this formula star because it will become useful later on. Now, since we are twisting this cylinder, there's a torque, but more specifically an internal torque. So it's not just at this point that the torque is applied, but throughout the entire radius. So to find the total torque, we'll have to divide the circle into incremental small rings, find the torque of each of these rings, and sum it by integration. Torque we know is force times radius, so the incremental torque will be tau dA times the small r, the small radius of the incremental ring. This formula comes from the fact that tau is stress, which is force over area. Therefore, force will be tau times area. But for the incremental rings, it's not the entire area of the circle, but dA, the incremental area of each ring. And this incremental area is equal to 2 pi r dr, since dr is the thickness of each of these incremental rings, will be the integral of all these incremental torques. The limits of integration are from the center of the circle to the edge of the circle, which is from 0 to r of dt. By star, we substitute tau for r alpha g over L and get torque is equal to the integral from 0 to r of 2 pi r alpha g over L times r squared dr, which is the integral from 0 to r of 2 pi r cubed alpha g dr all over L. 2 pi g alpha over L can be taken out of the integrand because they are constants, and what's left will be r cubed dr to integrate. After integration, we're left with capital R to the power of 4 over 4 times 2 pi g alpha over L. And solving for alpha, which is the result that we want in this video, we result in 2dl over pi g r to the power of 4, which is the final result.